Hello, so this is 5.3 part 2. It's going to go pretty quickly today. And I'm going to start off with two jokes. First joke is, can a kangaroo jump higher than the Empire State Building? And the answer is, of course, the Empire State Building can't jump. And then the second joke is, how do astronomers organize a party? Well, they just plan it. Okay. So, what we're going to do next is simplify complex fractions. Okay? So, a complex fraction is, well, an example of one is something like this. You've got fractions in your numerator and fractions in your denominator. It's like fractions within fractions. It's like fractionception. So this is what you're looking at. You got 2 over x plus x over 4, and that's your numerator, and then all of that over x plus 1 over x. So do you remember that when you divide fractions, all you have to do is flip the denominator and then multiply them. So that's what I'm going to do. I'm going to rewrite this as 2 over x plus x over 4 times the reciprocal of this denominator. So that's x over x plus 1. Now we learned earlier in 5.3 that when you're adding or subtracting fractions, you have to make their denominators the same. So inside this set of parentheses, there's 2 fractions that are being added. Right here, this set of parentheses is being multiplied by this complex, by this, and so we don't have to worry about those denominators. We just have to worry about these 2 denominators if we want to be able to add 2 over x and x over 4. So what I'm going to do is I'm going to multiply each of these by the denominator that they don't have. So this is an x, and this is a 4, so I'm going to multiply this one by 4 over 4. Hopefully green is green's not really good. I'll do that in red. 4 over 4, multiplying it by the 2 over x. And then the x over 4, I'm going to multiply that by x over x. So now both my denominators are 4 times x. This is 4x, this is x times 4, it's the same thing. So now I can add these two. So I will do that down here, and I know that my denominator now is 4x. Okay. And then I've got 4 times 2, which is 8. X times x is x squared, so 8 plus x squared on top. I'm going to get rid of this parentheses. And then all of that is being multiplied by this one. So it's going to be times x over x plus 1. Now this, you might be tempted to get these denominators the same. And if we were adding these fractions or subtracting them, you would be correct. But since we're multiplying them, what we can do, what we learned in 5.2, is just extend this line straight across and multiply. So if I'm going to extend the line, I want to put parentheses around them so I know what I am multiplying. And then I'm just going to go ahead and multiply these across. So we've got 8 times x, that's going to be 8x. And we've got x squared times x, that's going to be x cubed. 4x times x is 4x squared. And 4x times 1 is 4x. Okay, this is a plus sign. little sloppy. That's a plus sign right there. Okay, now I want to factor these a little bit, the top and the bottom. So what can I take out of my numerator? I can take out an x, so I'll do that. So we've got an x is going to be equal to, or excuse me, it's going to leave us 8 plus x squared. And then the denominator, I can take out a 4x. So I'll take out a 4x, and I'm left with x plus 1. Now, do you see anything in here that can cancel out? Well, we've got an x here and an x here, so those we can cancel those out. So I'm going to cancel this x out with this x. And it doesn't look like I can do anything else, so I'm left with 8 plus x squared over 4 times x plus 1, so I'm going to distribute that. It's going to be 4x plus 4, and that is my final answer. And we can assume that all expressions are defined, so we don't have to figure out where x is equal to 0. And that's how you do those. So, 2 more examples for you. And you can pause the video and try these on your own. I'm going to go ahead and do them right now. So, we've got a fraction over a fraction. This is a complex fraction, so what I'm going to do is flip the denominator and multiply across. So I've got x plus 1 over x squared minus 1 times x minus 1 over x. Okay. Now, before I start trying to cross things out, can I simplify this in any way? Well, here we have a difference of squares. X squared minus 1 is equal to x minus 1 times x plus 1. So I'll rewrite this as x plus 1 over x minus 1 times x plus 1 multiplied by x minus 1 over x. And now I can start canceling things out. We don't have to get these denominators the same because we're multiplying. So they can just stay as they are. If we were subtracting or adding, you would want to get them the same. But we don't have to worry about that. So we've got an x plus 1 on top and x plus 1 on bottom. We've got an x minus 1 on top and x minus 1 on bottom. And we're just left with 1 over x. Nice and easy. That was pretty cool. Okay. This one, I'm going to do the same thing. I'm going to flip the denominator and multiply straight across. So I've got 20 over x minus 1 times 3x minus 3 over 6. And I could pull a 3 out of here, but I think what I'm going to do is go ahead and multiply straight across and then see if I can simplify it from there. So 20 times 3x is 60x. 20 times negative 3 is negative 60. And then I'm going to multiply this 6 with this x minus 1, and I get 6x minus 6. Okay, now, what do you want to pull out of the top and bottom? Can we factor the top and the bottom? Well, we can pull a 60 out of the top and a 6 out of the bottom. So I'll go ahead and do that. We've got 60 times x minus 1 over 6 times x minus 1. These x minus 1s cancel out. We're left with 60 over 6. 60 divided by 6 is just 10. And that's your final answer for that one. Okay, so this is the last slide, and this is going to be a word problem that involves a complex fraction. A freight train averages 30 miles per hour traveling to its destination with full carts, and then 40 miles per hour on the return trip with empty carts. What is the train's average speed for the entire trip, round to the nearest 10th? So it wants to figure out the average speed. Speed, if you think about miles per hour or meters per second, speed is always measured in distance over time, right? So we're going to have to come up with a formula that is distance over time. So my total distance, I'm going to use the formula 2D because there's two different speeds, and one distance was one on the way out when we had fully loaded cargo, and then another distance was the same exact train tracks on the way back with no cargo. If you're a marathon runner, you would call that an out and back. Not as much fun as what we call loops, which is where you go on you don't cross the same path twice. Anyway, but this is about trains, so stay on topic. Now I've got my distance. I'm going to use 2D, and I want to find my average speed, right? That's what we're looking for. What's the average speed? So remember I said speed is distance over time, so I know that my numerator is going to be 2D. And then my denominator is going to be time. Now, if you were to reread this, you would notice that there is no time that's given to us. But they do give us a unit that has time in it. Miles per hour, right? Speed. Hour, that's your key word, that's time. So, that's in miles per hour, distance over time. Is there anything we can do to the speed to get rid of the distance and only have time? Well, you can multiply it by 1 over d, and then these d's are just going to cancel out. But then our time is still on the bottom, so that wouldn't really work. We can't have it on the bottom. So we have to figure out how to flip it. What you can do is you can make your speed the denominator of distance. So write something like distance over time. That way you would have to take this denominator, flip it, and multiply it to this d over 1. And then that d would cancel out, the d on the bottom would cancel out, and you're left with time on top. So that's what we're going to do over here. We're going to have distance over our speed. And we have two speeds that we're going to use. That's why another reason why I put 2d for our top, so we've got the same number of things we're working with. So our first speed is 30 miles per hour, so I'm going to go distance over 30, and then we're going to add distance over 40, because that was our speed on the return trip. Now, you are working with this lovely formula right here. This is a complex fraction. Lucky for us, we know what to do with these. On the denominator, you've got a fraction being added to a fraction. And if you remember from the first part of 5.3, the way you deal with these to be able to add them together is you got to change the denominators so the denominators are the same. So I have a 30 over here and a 40 over here. So I'm going to multiply this whole fraction by 40 over 40. Hopefully that shows up well on your computer screen. And I'm going to multiply this whole side by 30 over 30. Okay? Now I'm going to rewrite this. So we've got the average speed is 2d over 40d over 40 times 30 is 1,200 plus 30d over 1,200. And now these fractions have the same denominator, so we can just add them. So what I'm going to do is rewrite this as 2d over 40d plus 30d all over 1200. So 40 plus 30 is what? 70. 70d over 1200. Now I've got this 2d over this fraction here. So what I'm going to do with that is I'm going to flip my denominator, move it up here, and multiply straight across. So we've got 2d, and I'll write 2d over 1, times the reciprocal of this. So 1200 over 70d. Okay, now we can just multiply straight across. And we've got 2d times 1200 is 2400. 2400d over 1 times 70d is 70d. Now, these d's cancel out nicely, and then we're just left with 2400 over 70, so I'm going to plug that in my calculator. I don't have one on the screen, so I'm going to use this one. 2400 divided by 70 is equal to 34.28 miles per hour. So our average speed is 34.3 miles per hour. And it makes sense that that is average because that's between 30 and 40. So there you go. That is how that one works. And I'm not going to have you do the lesson quiz, so that is our last slide for today. Great job. Happy math.